So this is on the integrated rate equations. So here is the index. I am going to talk about the integrated rate equations. Under that, zero order reactions, first order reactions, the characteristics of first order reaction, and about the half-life of your reaction. These areas we are going to look into. So integrated rate equation is one of the important one which indicates how we are going to integrate to move to the next level of reactant into a product. And we are going to talk about the zero order reaction, how it's occurring, and also the first order reaction. So what is rate equation under first order reaction is one area I am going to focus. Apart from this, I am going to talk about the characteristics of first order reaction, what are the characteristics, and finally the half-life period. So how the data is reduced or died half-life. So let's move on. Integrated rate equation. The concentration dependence of a rate is called a differential rate equation. It is not always convenient to determine the instantaneous rate, as it is measured by the determination of the slope of the tangent at point t in concentration versus time plot. Here is the graphical view of energy versus a reaction coordinate, and you are able to see the reactants here. You got the reactants here. Once if there is a change happening, the reactants will become a product now. Now the product is created. But the energy which is really reduced, it's delta H minus, which indicates the energy is released. So energy is released, that's referred to as exothermic reaction. Over here you are able to see the reactants are there. Once it becomes product, the delta H is positive, which indicates its exothermic reaction. So reactants need some energy to convert into a product of energy. Standard enthalpy change is the heat energy transferred under standard condition, the pressure of this one, temperature of this one. In order to avoid this difficulty, we can integrate the differential rate equation to give you a relation between directly measured experimental data, therefore concentration at different times and rate constant. The integrated rate equations are different for their reactions of different reaction orders. We shall determine these reactions only for zero and first order chemical reactions.